All right, problem number 6. So we have a block. This slope is entirely smooth, and then it slides to rest on a horizontal floor like this. So what's going to happen? All this potential energy, as it slides, it gets converted into kinetic, and when we reach the bottom here, it's pure kinetic energy because all this potential energy has been converted into kinetic because there's no friction to dissipate any energy here. So there's no thermal energy as it slides. However, from here to here, the surface is rough. There is friction, and therefore all this potential energy finally gets converted into dissipated or thermal energy. So we have potential to kinetic to thermal, choice D. All right, problem number 7. So we are just doing another ratio question. So we have kinetic energy and momentum, and we're going to be comparing two situations. So we have K1 equal to P1 squared over 2m, and K2, which is P2 squared over 2m. And let's just be clear, we have m1 here and m2 here. Why am I using this formula for kinetic energy? Because they mentioned momentum in the problem. That's why I want to use this particular formula. Now we're told that they have exactly the same momentum, so I'm just going to say K1 is, I'm just going to say that K1 is just plain old P squared over 2m1, and K2 is just plain old P squared over 2m2. Now let's get the ratio. So we want to know what K1 over K2 is. That's going to be P squared over 2m1. And remember, to divide by a fraction is to multiply by its reciprocal. So this is 2m2 over P squared. The P's cancel, the 2's cancel, and we're getting that this is m2 over m1, which is choice A. Then, problem number 8, we have a rocket that's fired vertically, and we want to know what happens to the momentum of the kinetic energy as a result of the explosion. Now, if they had said total energy alone, okay, choice B would be correct if total energy, or rather total energy, was asked. But they're asking for kinetic energy. Now here's what this means. Sum of the chemical energy goes into the explosion and is converted into KE. So momentum is conserved, but kinetic energy increases. And that's how we are getting choice A as our answer. Cool. And problem number 9. So this is a simple question of, we want the work, so let's get the force, the area under the force versus displacement graph. So the area is going to be 1/2 base times height, which is going to be 1/2. The base is 2 times 10 to the negative 2. The height is 5. And so I'm going to end up getting 5 times 10 to the negative 2 joules, which is choice C. And then question number 10. Question number 10, we want to know the correct expression for the work done by the force. So when we have a force pointing one way and a displacement that's the other way, and we want the work done, that's going to be work is F times D times the cosine of the angle between the force and the displacement. So there really isn't a lot of math here. This is kind of a definition you need to memorize. So this is question number 10. And we'll take a look at 11 through 15 in the next, or rather the last video for this unit.